Hello, my name is Bob Kostemba, and I'm a Principal Solutions Architect with Red Hat. Today I'd like to demonstrate how Red Hat Enterprise Linux 7 can be used to manage and monitor HPC workloads. During this demonstration, I'll be using three applications. On the far right of the screen is Performance Copilot, or PCP, a system monitoring tool that is included with RHEL 7. This charting tool can be used to monitor a number of system metrics, including CPU and memory utilization. The line chart at the top will graph how busy each CPU is executing user code. The server being used in this demonstration contains 4 physical cores, which correspond to the colors in the graph. In the upper left is a CPU-intensive, multi-threaded, real-time ray tracing program, and in the lower left is a demonstration program that is used to modify control group parameters. Control groups, or cgroups, is a kernel mechanism used to enforce resource controls on applications. To set the stage, let's take a closer look at the ray tracer program. The ray tracer is running at approximately 30 frames per second using a single thread. The top PCP chart indicates that all system processes are migrating between the 4 CPUs, which is the default behavior of the fair share scheduler. If you're wondering why CPU 0 appears slightly busy, is because I'm running a screen capture program along with the ray tracer. Now we'll run the ray tracer using 4 threads. Notice the frame rate has increased to 60 frames per second and all 4 CPUs are hard at work. As indicated by the PCP chart, this program is consuming nearly all of the computing resources of the server. Next, we'll use cgroups to constrain this resource-hungry application. The single-threaded version of the ray tracer is now running in control group number 1. The ray tracer can be pinned to CPU 0 by changing the CPU set parameter to 0. Observe the PCP chart and notice how busy CPU 0 is. This feature can improve cache contention between HPC applications within the same server. Now we'll run the ray tracer using 4 threads in the same control group. By pinning the ray tracer on CPU 0, its frame rate is limited because all 4 threads are running on a single CPU. Notice that the remaining CPUs are nearly idle. Finally, we'll use cgroups to set a hard CPU quota on the ray tracer. By setting the CPU quota parameter to 30,000, this program will never consume more than 30% of CPU 0. Notice how the frame rate has dropped considerably and the Performance Copilot chart indicates the CPU activity. CPU quotas are useful in multi-tenant computing environments such as a platform as a service. For more information on how Red Hat Enterprise Linux can be used in your HPC environment, visit our website at rel.redhat.com. And thanks for watching.